Fantastic.
Thank you.
Okay. Hi, everyone. Yeah, to start off, I just wanted to thank you all for being so understanding about having to change the time. I'm really sorry for having to cancel Thursday's class, and appreciate everyone's um, flexibility with this. So let's get started. For folks that aren't able to attend today's class, we're gonna just post the link and they can also watch the recording of that. Okay. So I think we're gonna pick up where we left off when it came to if and elif and else statements, and we're gonna do a little bit more of a challenging example where we take OHIP requirements for how you can get an eye examination, and then we take those requirements and translate them into code. Today, we're also then going to talk about some more data types. So up until this point, we have discussed integers, which are whole numbers, floats, which are decimal points, strings, which are text, and Boolean values, which can be true or false. We're going to build on these today and introduce a couple more data types. And these are different in that they are collections of values. So we'll see examples of lists, tuples, sets, and then also dictionaries. And rather than having just a single value, these data types can store multiple values. So we're going to go through those, and then we're going to wrap up by going over loops. So we're going to discuss two kinds of loops, for loops and while loops. And they allow us to repeat code for a certain number of times or until a condition is met. So that's an overall summary of what we'll be doing today. And we can get started now. Okay. So we had discussed the if, elif, and else statements. And we explained that up until this point, our code has been running more or less linearly, where we run the first line, the second, third, and so on. Now, if, elif, and else statements allow us to only run code if a condition is met. So let's go over an example with OHIP. I'm just going to share my entire screen. Oh, no. There we go. So on the right, you should see the OHIP requirements, and then on the left, you should see my VS Code. All right. So we're only going to focus on eye exams for this example, and we're not going to incorporate the minor assessments into our code. So we're going to actually define a function. So if you remember, the way that we define a function is by having the keyword def. Okay. Then we have our function name. Our function name can have letters, digits, and underscores. It cannot start with a digit, and it is case sensitive. Usually functions start with lowercase letters. Okay, so that's our function name. We're going to have parentheses. And then inside of these parentheses, we're going to have our parameters. Remember, parameters are local variables that are used inside and only inside of the function. When we call a function, we pass arguments, which are then assigned to those parameters. Okay. So now I have my parameters, age, qualifying condition, time since last exam. And then I have a colon. Okay. I hit enter, and you'll notice that my cursor is now indented. That's important in Python. Okay. And then let's start with our conditions. So I'm going to take age as a number, as an integer. Qualifying condition will be a Boolean, so it's going to be true or false, indicating whether or not you have a eligible medical condition. And then time since last exam will be how many months have passed since your last eye examination. Okay. So if we take a look on the right side of the screen, we can see that you can your criteria for whether or not you qualify for an eye examination covered by OHIP really depends on whether you fall into one of three categories. The first is if you are 19 years or old, 19 years old or younger. The second is if you are between 20 and 64. And then the last is if you're over the age of 65. Okay. So let's take those three groups and write some if and elif statements. So if your age is less than or equal to 19, and then we're gonna say, I'm just gonna put insert, right? We'll code in that part in a moment. Okay, so if you're younger or equal to 19, we're gonna do something. Elif 20 less than or equal to age less than or equal to 64. Otherwise, if you're between the ages of 20 and 64, we're going to do something else. So I'm just going to put insert, right? And then if you're between the ages, if you're greater than or equal to 65, oops, make sure you spell it correctly. Okay. Then we're going to do something else. And then if none of these conditions are met, then perhaps you put in an invalid age input, right? Maybe you put some sort of a age that we can't execute any of these three conditions. Okay. So we're just going to then have a catch-all. Think about that else as your catch-all, and we're going to say invalid age input. Okay. Yes, there's actually a really great question in the chat saying, could you please recap the use of elif versus elf? So when you have a if statement, right, it's only going to evaluate anything inside that evaluates to true. You can also have an else statement, and that is going to tell Python what code to run if all the statements prior to it executed to false, right? It's like your catch-all. And if you'd like, in between, you can have elif statements. Now, these, the minute that you encounter the first statement that executes to true, it's going to execute the code inside of it, and then it's going to skip all of the subsequent elif and else statements. So I'll repeat that again. Here, we execute the if statement. If it's true, we do whatever code's inside of it, and then we skip all of the subsequent elif and else statements. Let's say this condition was false, but now this condition was true. We would then execute all of the code inside of that statement and then skip all of the subsequent elif and else statements. And the same goes for the next condition as well. Okay, great. So let's start filling in all of these little blanks. Okay. I'm also going to just select my kernel up here. So if you haven't done that yet, make sure you select your kernel. Okay. All right. So we can see on the right side of my screen that children and youth that are 19 years or younger are eligible for an eye exam covered by OHIP once every 12 months. Okay, so now we have to make sure that it's been at least 12 months since your last eye exam, and then you will qualify. If not, you won't qualify. So we'll say if time since last exam is greater than or equal to 12, oops, okay, then return you are eligible for one major eye exam and any minor We'll just include the minor assessments in there and any minor assessments, okay? Why are we having a return statement? When you have a function, right? The minute you encounter a return statement, you're going to exit out of the function. So we return this value, and then we are done executing that function call. We could have a print statement here, right? And in this case, it would print that statement. However, oh, yeah. However, if you print that statement, you aren't getting any output that you can assign. And I'll go through an example when we start calling this function, we'll see what I mean. But if you said, for example, that you were going to call this function and you were going to say, I exam covered, and you said, hey, I'm 15, I don't have a qualifying condition, and the time since my last exam was 13 months, right? If you wanted to assign a variable to be the output, so if you said value, and you had just printed the statements, you wouldn't get any output being returned, and you wouldn't then be able to assign that value to this variable name. So that's why you can have a return statement here. Now we can assign this string as the string is the output, and it can be assigned to this variable value. Again, we'll go over this once we finish filling in all of these blanks, and hopefully that will become even more clear. Yes, thank you. I think there was a comment. Oh, no. Yeah, there was a comment in the chat that said this should be if you're greater than or equal to 20 or less than or equal to 64. So that is correct. Apologies about that typo. Okay. So, if you're younger than 19 and it's been more than 12 months since your last exam, we're going to return you are eligible for one major eye exam and any minor assessments. Okay. Otherwise, we're going to return it hasn't been 12 months since your last major eye examination or exam, okay? So we're saying, hey, if you're younger than 19 and it's been more than 12 months since your last eye exam, you're eligible. If it hasn't been more than 12 months, you are not eligible. Let's move on to the next age category. So if you're between the ages of 20 and 64, okay, it
Okay.
says, yep.
I think the 20 should be smaller than and equal than age, right?
Oh, yes. Sorry. I
Like,
think I got confused. Yes,
yeah.
you are completely right. Thank you, Moniz, for correcting that. I got a little thrown off looking at the chat, but yes, sorry. That's correct. The age is greater than or equal to 20, right? But less than or equal to 64. Thank you. Sorry about that. I hope that didn't cause too much confusion. Okay. So, if you're between 20 and 64 and you have an eligible medical condition, okay, so first we have to see if you have an eligible medical condition. So let's say if qualifying condition. So this is going to be a Boolean. It's going to be true if you do have an eligible medical condition, and it's going to be false if you do not have an eligible medical condition. Okay. If that one evaluates to true, then if it has been more than 12 months since your last eye exam, you now qualify for another one. So we'll say if time since last exam is greater than or equal to 12, okay, return, you are eligible for one major eye exam and 2 additional follow-up minor assessments. Okay. Otherwise, else, we'll say return. It hasn't been 12 months since your last major eye exam. Okay. Now, if you don't have a eligible medical condition, we're going to return the statement, you do not have an eligible medical condition affecting your eyes. So let me go over this again. Okay. If you are between the ages of 20 and 64, we first need to check if you have an eligible medical condition. So we're saying if qualifying condition is true, so if this has a Boolean value true, then execute some code that will then check again if you do qualify. If you don't have a medical condition, you automatically do not qualify. So then we're going to return this sentence saying you do not have an eligible medical condition affecting your eyes. Let's go back up to what happens if you do have one. If you do have a qualifying condition, you get an eye exam once every 12 months. So let's check our first condition. And if the time since your last exam is greater than or equal to 12 months, we're going to return this sentence. Otherwise, we'll return this sentence saying it hasn't been 12 months, right? Okay. Okay. Now let's go to the last age category, which is if you are 65 years and older. OHIP will cover your eye exam once every 18 months. So in this case, we just need to check if time since last exam, I'm going to hit tab on my keyboard and it will autocomplete, is greater than or equal to 18. Okay. Then we're going to say you are eligible for 1 major eye exam and 2 additional follow-up minor assessments. Okay. Otherwise, we're going to say return. It hasn't been 18 months since your last major eye exam. Okay. So again, to summarize this age category, if you are greater than or equal to 65 years old, you qualify for an eye exam every 18 months. So we're going to check if it's been at least 18 months. If it is, we'll say you are eligible. If it isn't, then we're going to say you are not eligible. Okay. So this is a little bit more of an involved example. I wanted to demonstrate how we can nest those if, elif, and else statements within each other. Are there any questions about this so far? Okay. Okay. Yes, I see a hand up. Yep, Saliha, I can answer your question first if you, I'll ask to unmute. Let me know if, there we are. Oh, sorry, I think it's a little bit, I don't know if there's anything you can do to change the sound quality. Perhaps it's still not audible, but maybe if you want to type your question in the chat, we can address that. Okay, I'll keep an eye on the chat for that question to come in. In the meantime, let's try calling our function. So I'm just going to run this. Just deleting that. I'm going to run this to now define the function. Okay, so now our function's being defined and we can go ahead and use it or call it. So let's say eye exam covered, okay? And let's say we are 15 years old. We do not have a qualifying condition. And the time since the last exam has been 13 months. Oh, I'm just going to take a pause on that. I see the questions being typed into the chat. What's the best way to identify the total number of parameters? If you remember last class, we had discussed how you can actually have a doc string, which, which we indicate with having 3 quotation marks on either end. And then across multiple lines, you can go ahead and explain the function, its inputs, its outputs, what it's doing. So you can always go ahead and explain further on the parameters inside of that. We selected just 3 parameters for this to keep it simple, but you can always add more detailed parameters if you'd want to check more conditions. Okay, so we're 15 years old. We do not have a qualifying condition, and it's been 13 months since our last exam. So this first if statement is going to execute to true. We then enter into the indented code, which is everything I've just highlighted. The next if statement is an evaluated, and the time since our last exam is greater than 12. So we're going to return this sentence. You are eligible for 1 major eye exam and any minor assessments. Okay. Now, I mentioned the difference between having a return statement and a print statement. If I had here, okay, this variable eye exam output, I can assign this variable to be the output of this function call. And now I can reference eye exam output and it's assigned this string value, right? The difference is when I have print, oops, sorry. Okay. If I go ahead and run this now, we'll see when the function is called, it actually prints out that value. So this is what I'm getting. It's printing out that value. However, it doesn't actually return an output. It returns that none, which is a special data type that essentially means nothing. So now if I look at the value of this variable, we can see that it's none, right? It doesn't have any value assigned to it because the function didn't output anything. We just printed inside of it, but we never returned a value. So that's why we use the return statements here. Okay, so I'll go back and I'm just going to redefine the function and then run these 2 cell blocks again. Okay. Let's take a look at another example of when we call this. So if I do eye exam covered, actually I'm going to do eye exam output is assigned the value of eye exam covered. When let's say we are 27, we do not have a medical condition, and it's been 24 months since our last eye exam. Okay. We get back this sentence saying you do not have an eligible medical condition affecting your eyes. So if we take a look, I said we were 27, right? So we did not meet this condition, but we did meet this condition. So now we can go ahead and execute the code inside of that elif statement, which is everything I've just highlighted. Do we have a qualifying condition? This actually evaluates to false, right? Because we said false. So now we're going to execute the else statement and return you do not have an eligible medical condition affecting your eyes. The return statement also indicates to Python, okay, you're done running this function call, exit out. Okay? And then that's why the output is this string. You do not have an eligible medical condition affecting your eyes. That string is assigned to this variable eye exam output, and you can see that here. Okay. Okay. So that was everything I wanted to discuss when it came to if, elif, and else statements. We had introduced them in our last class, and then right now we just did a little bit more of an involved example with nested if, elif, and else statements. Okay. I'm just checking the chat. Since there is no qualifying condition in here, it is always false. No, you can assign a default value if you remember how we had done that in one of our earlier classes. So you could say default to be always true, right? Or default to be always false. So that is something that you can also play around with. Okay. But unless if you do not specify a default value, it is not going to assume anything, right? Otherwise. So if you wanted to have a default, you would have to set it up here in the function header. Okay. I hope that answered the questions in the chat. Okay, we're going to now talk about collections of values and those new data types that I had mentioned. So again, so far we have discussed integers, whole numbers, floating point numbers, which are decimal numbers, and then strings, which we indicate by having single or double quotation marks on each side. They're text. And then we have Booleans, which can be true or false. But those have not been groups of values. So we're going to introduce a couple of data types that store and work with multiple values together. Okay. So we're going to introduce four. Let's start with lists. So we indicate that something is a list by putting values inside square brackets. So if I had, for example, a variable named vowels, okay, I could indicate that it was a list by just having square brackets. And then inside, I can put all of the elements of that list. So I can have the string A, E, I, O, and U. Okay, so the variable vowels is assigned to be a list, and it has 5 elements inside of it, which are the strings A, E, I, O, and U. So now let's print that list. I'm going to touch upon something we learned about in our last class, which is the F string. So if we want to format a string, one way to do that is to have an F, then to have the string itself. So I'm going to say, here are some vowels. Okay. And then you have curly braces, and inside of those curly braces, you can have the variables that you want to be formatted inside of that string. Okay. So now I see here are some vowels, and I can have the my list being printed: A, E, I, O, N, U. Okay. Sometimes we want empty lists. You can imagine, so we can actually append to a list or add to a list. And perhaps we want to start off with an empty one, and as we run other bits of code, we start to populate those elements inside of this empty list. So if you want to create an empty list, you just have square brackets with nothing inside. Okay. I'm going to say, so I'm just writing a little comment by having the number sign. I'm going to say this, create an empty list. And this is the conventional way of creating an empty list. Okay. So this is a conventional way of creating an empty list. You can also create an empty list by using the list function. So you could have empty list 2 is list, okay? And this would also go ahead, this is a list function, and that is also going to create an empty list. Okay. Also something to note is that values in a list can be different types. So we can have a mixture, right? We can have some elements be integers and some be floats. We can have some also have strings. So you can have lists with different data types inside of it. So if I said scores, I could have 90, 80, 82, 91, and 80. Okay, oops. And to prove what I said, if I have, you can have different data types. So I'm going to have the string character K, and then I'm going to also have some integers. Okay. And you can even have functions inside of your list. So we had introduced some built-in Python functions, length, sum, max, and min. Okay. So when I run this, the cell is able to execute, showing that these are all valid lists. We can even have lists within other lists. So as an example, we'll call our variable mystery solvers. Okay. And I'm just going to make it more readable. So I'm actually going to break this apart across multiple lines. So I said before, if you have something in parentheses, you can spread it across multiple lines to make it more readable. Same thing with the square brackets. We can spread it across multiple lines and make it a little bit more readable. So Sherlock, okay, and Watson. So this is indicating the outer square brackets are indicating that I have a list, and then the within that list, I'm going to have sublists. So my first sublist has this first element as Sherlock, and the second is Watson. Next one is going to be Scooby, okay, Shaggy, Fred, Velma, and Daphne. And then I'm just going to have Nancy. Okay. So I have one list, which is assigned to the variable mystery solvers. Inside of it, I have the first element as a sublist, the second element as another sublist, and the third element is just a string. So I now have this larger list with two sublists and a string. Okay. If you remember, when we were working with strings, we were able to access certain elements of that string or certain characters, right? And we did that by indicating the index or the position in the string that we were interested in slicing. If we wanted more than one character out of the string, we could go ahead and put colons indicating the start and the end indices. If you remember, the end indices it would always go up to, but not including that end indice or end index. So that's something to keep in mind. And we're going to see right now that lists behave in a very similar way when we are slicing them or indexing them as with strings. Okay, so let me go through an example to make this more clear. So up here I had defined this list called grades, right? And it had K for kindergarten and then 1 up to 12. So if I want to get this K I would then have to write the list name, and then I would have square brackets, and then inside of those square brackets, I would have the position or the index that I was interested in extracting. So if I do grades at 0, I get back K. Remember that in Python, everything is 0 indexed. So this is position 0, 1, 2, 3, 4, and so on. So again, if I was interested in getting the output at position 6, right, it would then index that list. So this is at index 0, 1, 2, 3, 4, 5, and 6. So I get back the value there, which is 6. Let's say I want to get all the middle school grades. That case, I would have square brackets, and I'd say I want the indices at position 6 up to, but not including position 9. So 0, 1, 2, 3, 4, 5, 6. This is what I'm interested in. So get me 6 up to, but not including 9. So 6, 7, 8, up to, but not including whatever's at position 9. And that's why I get this as the output. Okay. Just like with strings, we can have negative indices to count backwards from the end. So if I did grades -4, okay, I'm going to have -1, -2, -3, -4. And when I run this, I should get back 9. Okay. If you try to access an item at an index that does not exist, you're going to get an error. So if I tried to go grades at index 13, I'm going to get an error, right? Because I only go up from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't have anything at a position 13. So because of that, I get this error being thrown, okay? Are there any questions about how we can create a list using those square brackets, how we can have a list within another list, and how we can slice these lists in a way that is the same as with strings, where we indicate the position or the index of interest. If we want a range, we can have a colon. It will go up to, but not including that last index. And we can also have negative indices to count backwards from the end. So are there any questions about this? Yes, I see a hand up.
Yeah, hi Kylie. So if I want to print a particular list inside a list, how I need to do
Ah,
that?
yeah, that's a really great question. Okay, so we have mystery solvers, right, which was our nested list. If you wanted mystery solvers at index 0, okay, so the first element of mystery solvers is actually this list with Sherlock and Watson, right? If I did mystery solvers at index 1, this is index 0, right? Because we always start 0 indexed, and then this is index 1, and this is what I get back. Scooby, Shaggy, Fred, Velma, Daphne. And same thing if I do mystery solvers at index 3. Oops. 3 is out of bounds. It only goes up to 2. Then I get back, this is at index 0, this is at index 1, and then Nancy is at index 2. So I get back Nancy. Now let's say I actually want to access just this string, Sherlock, right? So the way you can do that is you can have mystery solvers at index 0, which is giving us Sherlock and Watson, because that's the 0th position. You have that first sublist. And then if you put another set of brackets and another 0, it's going to access the 0th index of that sublist, and then you get back Sherlock. Did that answer your question?
Yeah, thank you. I have one more question. And if I want to print everything inside the list, how I'm gonna do that?
Um, what do you mean? Maybe this is what your question is. If you want everything, you can just put colons with nothing on either side of them, and it's going to just output every,
Okay.
yeah,
Okay. Thank you.
no problem. Great. Okay. Do, do, do.
Yep. Can you explain slicing with like double colons? How does that work?
Yes, let me also refresh my memory on that. So if we have grades, I believe the middle one is telling you, I want to say the interval that you would be getting it, but let's try it out. If I go 1, 2, actually, let's see what's happening here. Do, do, do. Let me think. So the first, I think what's happening is the first one, let's test this out, and I will also just check and do a quick Google search in a moment. But I believe the first one I want to say is telling you the starting index. The second is telling you the end index, and then this third one is telling you the step, so the intervals that you would be taking. So I think what's happening is it's saying start slicing at index 1. Maybe a better example would be if I went up to 8, right? Okay. So start at index 1, go up to but not including index 8, but go in steps of 3. So I think then you would go index 1, and you'd jump 1, 2, 3. Then you'd print out 1, 4, and then you'd do another hop again, and you go 1, 2, 3, and you'd print out 7. Let me just triple check that that is correct on Google. 1 second. Okay, yes, that's correct. So did that make sense? Do you want me to go through another example maybe? I don't know who asked that question.
No, that suffices. Thanks.
Okay, perfect. Yeah, so again, start, end, and then this last one is the step.
And if we won't give the ending index, it will go through like complete list, right?
Yep, that looks like that is correct. Yeah,
And if we won't give like starting index, starts with 0, right?
yeah, yeah, that's
Okay.
right.
Yeah, okay.
Okay,
And if we won't give like anything in it, just 2 dots, it prints the whole list then.
yep, that's right. So yeah, you can play around with it on your computer, but and like put in different start, ends, and steps, but that's
Yeah, yeah,
correct.
yeah. Thanks.
No problem. Okay. Um, when we were learning about strings, we had learned about the in operator, which was really handy when we wanted to search for a substring within another string. So we can also use that in operator when it comes to lists. So if I had vowels, and if you remember, this is how we defined vowels earlier, you can have E in vowels, okay? And we're searching for this element within the list vowels. So it returns true when it's able to find it, but it's going to return false if it's not. So if I had K, it would return false. It's just a really handy little operator that you can keep in your toolbox. But yeah. Okay, we're going to introduce a very important concept now. Before that, I actually wanted to just make a note. Lists are ordered, okay? And what does that mean? It means that each item in a list can be referenced by its index or position in the list. Okay, this is what we saw when we were doing all of these when we were indexing everything. Actually, maybe it's better to put that up a little higher. Okay, yeah, here. So the point is, the reason we're able to index something is that lists are ordered, okay? Which means that Python is actually considering the position that the elements are in, and it's remembering those positions. So because of that, we say a list is ordered, and we're able to index or slice parts of those lists. Okay. So lists are ordered, and they are also something called mutable. So we're going to talk about that now. Lists are mutable, which means they can be modified in place. Okay. We have also learned about some immutable data types so far. We've learned about strings, integers, and floats, and those are all immutable, which means they cannot be changed in place. So I'm going to go through an example now, and we're going to talk about some sandwiches in a moment. So you'll see what I mean, and hopefully that will be a little more clear. Just to kind of get going on this concept of mutability, if I had a list called perfect squares, had the values 1, 4, 9, 16, 27, 37, and 49. Notice here that 37 is incorrect. Okay, so I can go ahead and fix that error and say change the element at index 5 to 36. And I can see now it's being updated accordingly. Okay, so this is showing that you can modify your list in place. And we're going to go through an example right now with sandwiches. Oh, sorry, I think I've been sharing my entire screen. I hope that wasn't too small for folks. And I hope you were all able to read the VS Code. But now you should see on the right a PowerPoint slide with some sandwiches and then some lunch boxes. Okay. Actually, I'm gonna go back. So I think I had shown this slide in our first class. I'm gonna just go over this again. So if I have a variable a and it's assigned a value of 1, right? So a is assigned a value of 1. And I now take b and I assign it to have a value of a. You can see b is now also having a value of 1. But if I change, if I update the value of b to be 2, right? So I now update, or if I actually update the value of a to be 2, okay, and I keep b as 1, now they are, now a has updated to 2, but you'll notice that a is now 2, okay, and let's see, the value of a is now 2, but b still has the value of 1. Okay, so this is how immutable data types work. So I'll repeat that again. Let's say a was assigned a value of 1. Okay, a is assigned a value of 1. You can see that's what I have on my screen on the left. Okay, let's check. A has 1. Great. Now b is assigned a value of a. Okay, so if you see my, so if b is assigned a value of a, right, that's what we're seeing on the screen, then b is going to now also have a value of 1. If I change a to now have a value of 2, the important thing to remember is a now creates its own new value in a new location, a new memory location, that is, in Python. So now a has a value of 2, but it's created its own new location in memory, and it has that value 2. And because of that, b is still referencing the original memory location and the original value. So b still has that value of 1. Okay. So this is the behavior that we saw when it came to immutable data types, such as integers and floating point numbers and strings. We're now working with lists, which we've said are immutable. So let's see what we mean by that. If you have, so let's go back to the sandwich example. Okay. So let's go over the immutable side. So if you look on the left, right? Okay. let's say I have Moniz, right, is assigned the string cheese sandwich. Okay, so Moniz is having a cheese sandwich for lunch. And notice how cheese sandwich is a string, and this is an immutable data type. So I'm going to put, oops, immutable. Okay. Now, so Moniz is cheese sandwich. I also want a cheese sandwich. So I'm going to say Kaylee is assigned the value of Moniz. Okay. So now Moniz has a cheese sandwich and I have a cheese sandwich. Let's say Moniz now decides that she wants a ham sandwich. Okay. If that's the case, Moniz now has a ham sandwich, but I still have a cheese sandwich, right? Because let's see, Moniz gets a ham sandwich, but I'm still pointing to that memory location, that lunchbox, where the cheese sandwich is located. Okay. So Moniz had a cheese sandwich. I also wanted a cheese sandwich. So we were both pointing to the same lunch bag, right, with a cheese sandwich inside of it. Moniz then decided that she wanted a ham sandwich. So the way that Python works with an immutable data type is Moniz got her own lunchbox, her own location in memory with that ham sandwich inside of it. And I was still having for lunch that old lunch bag, that old memory location with the cheese sandwich in it. Okay. Now let's talk about what happens with a mutable data type. So we said that lists are mutable. So if I have now, let's say Moniz, okay, is going to have bread, cheese, bread, okay? So now Moniz, now we're looking at what's on the right side of this PowerPoint slide, okay? So Moniz is a variable assigned to a list where there are 3 strings, 3 elements, bread, cheese, bread. Okay. Now, I also want that bread, cheese, bread list or sandwich. So I'm going to say Kaylee is assigned a value Moniz. Okay. So if I take a look at this, I have Moniz, bread, cheese, bread, Kaylee, bread, cheese, bread. Okay. And this is what's on the top row where my cursor is circling right now. Moniz and Kaylee are both pointing to this lunch bag with a cheese sandwich inside of it. Now, if I go ahead and change this Moniz at index 1, right? So this is index 0, this is index 1. And I say I want to change that element to now be vegetables, right? Okay. Or I guess we can keep it consistent, ham. Okay. Now if I look at Moniz, right? She has a ham sandwich, bread, ham, bread. But the interesting thing is, I also now have to have a ham sandwich. Mine has also updated to bread, ham, bread. And we're still pointing to the same lunch bag or the same memory location in Python. So with immutable data types, when you made changes to the values, Python will then create a new location in memory and it will put in that new value and you will have a completely separate value and location in memory. The difference is when you have a mutable data type, it's changing it in place in the same memory location. So it's updating those values in the same memory location. So everything that now references that memory location is also getting updated. So just because Moniz wanted a new sandwich, I also had to get a new sandwich. Okay. And we're going to talk about how we can create an independent copy. But this concept of mutability is pretty key. So I hope this sandwich example made some sense. Are there any questions about this? Maybe, okay, yeah, I see some reactions. If actually that was clear, and you feel comfortable reacting in the chat, maybe I can get a sense of how many folks were able to follow along with that. Okay, great. Fantastic. Okay. Um, do, 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 do. All right. Let's do one more examples with some A's and B's. Okay. So, this is kind of referencing that earlier example. If I had an A, right, and it's going to be assigned 1. 1 is an integer. Integers are immutable. So now we're looking at the behavior on the left side of the screen, okay? A is assigned a value of 1. Okay, so, and B, I want to assign that to have a value of A. So now A has a value of 1 and B also has a value of 1. And this is in, let's call it location 1, right? Now if I change A to have a value of 2, A now has a value of 2, but B still has a value of 1. When I updated the value, it actually created a brand new location and in that with that brand new value. So this is the behavior of an immutable data type. Let's see what happens when we have a list. If I had a list, A is 1, 2, okay? Now B is assigned the value of A, right? So A is 1, 2, and B is also 1, 2. Okay. Now, if I update A at, say, index 0, right? So this is the 0th index. This is index 1, 0 index, number 1 index, okay? So A is 0, and I want it to now be 6. Now A has updated to 6, 2, but B has also updated to 6, 2, because when I updated that value, I kept it in the same memory location. So everything that referenced or pointed to that memory location also was updated. Okay. All right, I hope that was clear. Let's talk about how we can make an independent copy of a list. So let's go back to food and let's say combo. And I'm actually just going to share the VS Code screen so it's a little bit larger for folks. Okay. So if combo is a list and it has burger, fries, and drink, okay? Then I'm going to say kid meal. And let's say I want to create an independent copy, right? You noticed before how if Moniz changed her sandwich, I also had to change my sandwich. I don't want that to be the case here. I want to create an independent copy of that list. So I'm going to say make. So if that's the case, you can use the list function, and the list function is going to take combo and create an independent copy and assign that to my variable kid meal. Okay. So now let's see, combo is burger, fries, drink, and kid meal is also burger, fries, drink. But if I update combo at index 0 to now be a chicken sandwich, okay, kid meal, since I created an independent copy for kid meal using that list function, kid meal is not updated. So I can change combo now without changing kid meal because I've used this list function to create an independent copy. Okay. So again, the list function helps create an independent copy. Okay. There are a lot of ways to manipulate data in a list. So we can actually apply some operations. Okay. We're going to go over some functions. So if you remember, we had introduced functions and methods. And again, we're going to be talking about methods in a little bit more detail, hopefully on Tuesday or Wednesday's class, but yeah, here. But right now we were saying that when you use a function, right, you have the function name, and then in the parentheses you have the arguments. Whereas when you use a method, you have the object, a period, and then the method name, and then the parameters. Okay, so let's start by using, and we had seen how with strings, there were string functions and string methods that we could use, and we had gone ahead and manipulated those and tried them out. So let's do the same now with lists. So let's use some built-in functions. As a reminder, perfect squares. This was the perfect squares list. And if we use the length function, you put the function name, parentheses, and then the arguments. And you can see it's outputting the length of the list. And there are 7 elements, so we get back 7. Okay, we can also have this max function, which will return back the largest value in the list. And then we can have sum, which is going to be sum up all of the values, and we get 142. And so here we have some functions that we can apply to lists, okay? And we can even check that 142 is correct. I can just quickly add 1, 4, 9, 16, 27, 36, and 49, and I get back 142, right? Okay. We can also apply operators to lists. So before we saw when we had numbers like floats or integers, we could apply operators to them such as addition, multiplication, and then when we actually went and applied the same operators but now to strings, they behaved a little differently, right? Adding 2 strings together using the addition operator with 2 strings concatenated them. Multiplying a string repeated it that number of times. And we said because of that the operator was overloaded because it behaved differently depending on the data type that we were using it with. The same applies for lists, and they actually behave in a very similar way to our strings. So if I have a list and it's letters A, B, C, and numbers 1, 2, 3, characters, letters, plus numbers. Okay, so I'm applying this addition operator to my first list letters and my second list numbers. You can see I get back a concatenation of the two, right? That addition operator concatenated these 2 lists together. I can also take the letters list and apply the multiplication operator, and it's going to repeat the list twice, ABC, ABC. Okay, same with numbers. I can apply the multiplication operator, and now I have the list repeating 3 times. 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. But notice here that even when we apply functions and when we apply operators, so actually let me do perfect squares. So when we apply functions, right, here we've applied the length, max, and sum functions. The original list is not modified, okay? Because when you apply a function, it's returning back a value, okay? And the same thing, when we apply these operators, this multiplication, this addition, letters, and numbers, it's just returning back this value. It is not actually changing the list itself. So again, when you're applying a function, the rule of thumb is it's going to return back a value, and it's not actually going to change that list itself. And also when we apply these multiplication and addition operators, they're returning the values and they're not modifying the list itself. Okay. But if you apply a list method, right? So method, this is a syntax we use to call a method. If you apply a method, it is going to actually change the list itself. And as we saw when it came with the sandwiches and those A's and B's in that previous example, if we change that list, any other variable that references that list will also change. Okay, so again, functions typically do not change the list itself. They just return back a value. But on the other hand, methods usually do actually change the list itself. And because a list is mutable, any other variable that references that list is then going to update. Okay. So we'll go through some list methods now. And then I think that will be a good place to take a break. And then when we come back, we're going to go into start working through the remaining 3 data types that we have. So let's go ahead and see some list methods. Okay. The first one that I want to introduce is append. And yeah, append. So append is used to add a single element to the end of a list. It takes one argument, which is the element to be added to the list, and then I'll just actually say it takes an argument and adds that element to the end of the list. If the element is another list, it will be added as a single element. Okay, so let's see what I'm talking about. And then I think these comments will make a little bit more sense. If I have a list 1, and I say 1, 2, and 3, right? So this is my list 1. I can do list 1. And remember, this is a method. So I take my object, in this case, it's my list. I put a period. Then I have my method name, which is going to be append. And then my parameters, and let's say it's 4. So this doesn't return a value, right? Nothing's being returned. You don't see any output down here because it's a method, and usually methods will actually just modify the list itself. So it's now modified the list itself. It's taken this argument and added that argument 4 to the end of the list. So now we get 1, 2, 3, 4. If I had, let's say, list 2, and this is going to be 5, 6, and 7. And I said list 1 dot append list 2. Okay. It's going to treat this list as if it's another element and just add it as if it's another element, a single element. So if let's see what I mean by that. Now it's taken this list, right? 5, 6, and 7, and it's added it, just added it right to the end as if it's another element. So to repeat that, the main point here is that when we apply methods, we're changing the list in place, and any other variable that references that list is going to update. We've introduced 2 methods here, the extend and the append method. So append is used to add a single element. Sorry, we've introduced 1 so far, append. And the append is used to add a single element to the list. It's going to take 1 argument, which is the element that you're adding. And if you have a single value, such as 4, it's just going to be added at the end. if you have a list, it is going to be added right to the end. That entire list is going to be tagged on right to the end. Okay? It's adding it as if it's a single element. On the other hand, we have the extend method. So if you have list 1, again, let's redefine this, 1, 2, 3. Okay, let me put a little note. We can also have extend, which is used to add elements from an iterable to the end of a list. Unpacks, this is going to unpack the elements of the iterable. An iterable can be a list, a tuple, which we're going to talk about later. Think about it as something that is a collection of values, okay? And it's going to unpack each of those elements and add them one by one to the end of the original list. Okay. So list 1 is 1, 2, 3, and I'm going to say list 1 dot extend. Okay. And now I'm going to have 4, 5, and 6. Okay, so notice here, right? Before, when I had append and I tried to append 5, 6, and 7, it tagged it on as if it was a single element. Here, when I do have list 1 and I actually, I'll keep it the same, say list 2, just to keep it consistent with above, right? I have list 1, and then I try to extend with list 2. Rather than just taking list 2 and tagging it on as if it's a single element, the extend method actually goes ahead and unpacks each element one by one and adds them one by one to the end. So now it gets 4, 5, and 6. Okay. Did that make sense to folks? Maybe if I could get some reactions in the Zoom, that would be helpful. And I will close the side window one moment. Okay, fantastic. Great. Let's see another example with append and extend with another list called rainbow. I'm going to say rainbow is red. Oops. Orange, yellow, green, light blue, blue, and violet. Okay. So this is my list. Rainbow's my list. Take rainbow and I append purple. Right? It's a method, remember, so methods typically change the list itself, whereas functions typically return a value. So it's actually going to change rainbow, change the list itself, it's changing rainbow, and it's adding purple as a single element to the end, right? So purple just gets added. If I did rainbow.append purple as a list, it's now taking purple, the entire list, and adding that entire list as a single element just to the end. So this was the append method. On the other hand, we talked about how you could use extend. And extend would actually unpack each of the elements of your iterable. An iterable is a collection of values, something that you can iterate over. And in this case, we have a list with magenta and pink. And you can see it's unpacking each element of your list and adding it to the end one by one. So magenta and then pink. Okay. If you try to add a string, it's actually going to get broken up into single characters. So it unpacks each one of these characters and adds them to the end, one by one. And numbers don't work with the extend method at all. So if I did rainbow.extend 2.3, I'm going to get an error. I mentioned before, right, that functions return a value, whereas methods change your original list. So if I had new rainbow, right, this is a variable, and I tried to add append, okay, I tried to append and then assign that to new rainbow. New rainbow has no value. The value is none. If I try to print this, right, it has a none value because a method doesn't return anything, right? We're not getting anything returned to then assign it to this new rainbow variable. Instead, what happens is your methods just modify the original list in place. And that's what we can see here. Dark purple has been appended to the end. So I just introduced append and extend. Let's add on a third method called insert. So the insert method takes in the index and then that you want to insert the data into, and then the value that you want to put in. Okay. Oh, not value. Let's do indigo. Okay. And again, it's a method. So it's actually modifying that original list. It's not returning anything. It's modifying the original list. So if we look at the original list at index 6, so this is index 0, 1, 2, 3, 4, 5, and then this is index 6, we've added indigo. Okay. And if we did rainbow.remove P, you can also remove an item. So if we want to remove the P item, I run this and I look at the, it's a method, right? So it's modifying the original list in place. And I look at the list, you can see that it's removed this P, right? It's gone ahead and removed that P. Notice though, it only gets rid of the first match. So this P in for the pink, right? This is still here. Okay. So if you want to remove one or more items, you can actually use the del operator. Okay. So we can use the del operator, and then we say we want to remove everything from index -13 to the end. So it's gone ahead and it's gone from -13, which is here, right? -1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and it's gone from index -13 all the way to the end and deleted everything. Okay. And if you want to completely clear your list out, you can use the clear method. You can see that it's now completely empty. Okay. I see, oh, how do you get the negative in the index? Okay, yeah, if you want to provide, if you want to remove a specific value, I'm actually not sure if there's a way to provide the index number. I would have to look at the documentation. So maybe actually if you want to send me a message on Zoom, I can look in, sorry, on Slack, I can look into that afterwards. But off the top of my head, I'm not sure if there's a way to do it with the index. Yep, I see a hand up, Omer.
Yeah, Katie, I just want to ask that does the insert or remove methods they work with the letters also, or just with the letter with the numbers also, or just with the letters?
No, yeah, if you're that's a good question. If you
Because
have
I tried the thing with the list that we made,
Mhm.
the insert method, and it does give me a syntax error.
Oh, if you, for example, try to let's actually Let me
List
copy.
one dot insert, for example, 9 or something.
Okay, let's see. It should still work. So it should be able to insert a number.
Oh,
Try
maybe.
running things.
Yeah, I didn't give the position that like the first one where the index position is
Yes,
1.
yeah,
So I try to do that without that. So probably that was the reason. We have to give them a position where it need to insert the 9.
exactly. Yeah, if you
Okay.
actually look up the documentation online, and maybe I can just one moment, share my screen to show this.
It's just that the last 2, 3 things, the method that you told was a little quick for me at least to like grab upon. So I just wanted to like hold on to the thing and
Yeah,
try to understand.
absolutely. Yes, yes. No, that was a good question. Yes, so if I just share my whole screen, so if you see here, this is the document, some documentation I just typed in. All I Googled was list insert Python, and then I just clicked the first thing that showed up. And you'll see, right, the syntax is that you have to have there are 2 parameters, so you have to pass in 2 arguments. The first is a position, and the second is the element. So the position is the number, specifying what position to insert the value, and then the element is the element that you're putting in. So that's why when you just had one, it would throw an error because it required 2 arguments.
All right. Thank you so much.
No problem. Lisa, your hand is up.
Yeah, I have a question. So I'm looking at the GitHub notebook and it says what happens if we try to append data and assign the list to a new variable. So it goes like new underscore rainbow equals rainbow dot append and then in
Yeah,
quotations dark purple. And then it prints it and the result is none. So I'm
yeah,
just wondering if you can explain that part, like why
yeah.
it's
You
none.
can, yes. Yeah, you can see on my screen. Sorry, I might have gone over it a little bit too quickly, but we did do the same example where we appended dark purple and assigned that new rainbow and tried to print it and got back none. So what's happening here is I've iterated how functions will return values, right? And so a function will return a value, but it's not going to change the original. In this case, we're talking about lists. So it's going to return a list, a function, but it's not going to change the original list. Methods are the opposite. Methods will not return a list, but they are going to change your original list. They're going to modify it. So here we're applying a method, right? Because of the syntax is dot, and then you have your method name and then your parentheses with your parameters. So we're applying a method. So that means that it is not going to return a value, but it is going to change your original. So it's not going to return a value, but it's going to change rainbow. So because it doesn't return a value, there's nothing to assign to this variable new rainbow. And when we print it, we get back none. But if we look at rainbow, we can see it has added dark purple to the end. So a method, again, will not return a value, but it is going to modify your original, in this case, rainbow. Did that answer your question, or do
Yeah,
you want me to?
yeah, thank
Okay,
you so much.
no problem. Okay, great.
Kaylee, I just
Uh,
have one more request if you don't
yeah,
mind. Uh,
yep.
at least me, I suppose some of us try to do the live code as we should have been doing on our own Python notebooks. It's
Hmm.
just some of the time when you type long lists or something, it's a little difficult to like type all those things and to listen to you full like attentively. Is there a possibility that if you're typing something, a note that is a little longer or something, to put it in the chat or one of your TA can put that on the chat so we can copy that, the hashtag
Sure.
things or longer list so that we can be more attentive to you while listening.
No, that's a really good point. And I know, yeah, there's a lot of content and it goes very fast. I have actually done that in the past, but was asked from the Data Science Institute to kind of lean away from doing that, just when folks, a lot of questions would come on later about when they would reference the recordings, they wouldn't be able to also see the chat simultaneously. So I can go ahead and I know it's hard to type it all in quickly, so I will say two things. First is you can always reference the slides. For the most part, I follow the slides very closely. Sometimes I add a couple of new examples, but for the most part, it's very close to the slide content that I created. So you can reference those, and they will have those long lists that you can copy and paste.
Okay.
The second is I can, if there's times where it's very long, I can post it in the chat, but just for folks watching the recording, and also for everyone in the call, just be wary that the chat's not saved anywhere. So it's going to be gone once we stop the call.
No, yeah, you're right. But while we are listening to you, we can pause you, not in the
Yes.
live recording.
Yes.
Yeah.
Yes, that's true. So yeah,
But for the recording, we
I'll
can
put
always
it,
pause and type it up. But
yeah,
while
I
we're
can.
going with you, that's a little difficult.
Yeah, no, that's a great point. And I'll do that. Just a disclaimer for everyone that it's gonna all be gone at the end. Yeah, but you can
Thank you
reference
so much.
that in the slides. Okay, I know we've gone through a lot. I wanted to talk about sorting with lists, but I'm thinking it might be good to maybe take a break right now, and then we can do that when we come back. So let's take a break until 10:37, and then we'll reconvene and pick up with sorting lists. Okay. Great. I'll see everyone in a bit. 11 15 today, and then I'll go ahead and go over the assignment. So we'll spend some time at the end just walking through what's expected of you all. And a reminder too, given all of the changes with the schedule, we're going to extend the assignment until Monday at 11:59 p.m. Okay. And do some of the questions in the chat. Other logistics, no, sorry, the breaks are typically 10 minutes long during the live learning sessions. I think last week I just made it 15 because I wasn't feeling too well, but usually I try to keep it to 10. And there won't be office hours on Monday, but after today's live learning session from 11:30 to 12, Moniz and Pedram will be present to answer any questions, and they can also help you get started on the assignment. And then you can find all of my live coding notebooks are uploaded onto the GitHub repository. Moniz has also shared the path for that in the chat. Okay. So before the break, we introduced methods and lists for different lists. We said that when you're working with a method, it typically will change the original data. For example, in this case, working with lists, so it's going to change that original list. On the other hand, when you have a function, it's going to return back a new piece of data or a new list in this case. So that's the difference between the two. Okay. So let's go into sorting lists now. So I also said that lists are ordered in that they have a sequence of the way that the elements are arranged that Python considers and remembers. Okay. So because they're ordered, so because those elements maintain a specific sequence and that sequence is preserved by Python, we saw that we could access them by their index, right? So for example, I think we had grades, and I could do grades at index 4 because it's ordered, and then I can go ahead and extract out the value at index 4. Because they are ordered, we can also sort them. So we're going to go over a function to sort and also a method to sort. So I said that functions, typically functions will take a value and return a new value. Okay, so in this case, it's going to take a list as an argument and return a new list with sorted values. On the other hand, you can have methods. Typically, methods will will modify the value in place. So in this case, when we're talking about sorting and lists, we're saying that the method is going to take a list and reorder its values in place and return none. Okay. So let's go through functions first. I'm going to have a variable called veggies. It's a list. It's going to have potato, celery, cabbage, bell pepper, and onion. Okay. Make sure you spell veggies correctly. And let's see, let me move this actually to a new cell. Okay, let's see what happens when we have sorted function. Okay. So when I take the function, if you remember, the syntax is function name, parentheses, and then whatever the arguments are. So in this case, it's our list, right? So I have that. Then when I run this, it's returning a new value. That's why I have this output, because it's returning the value. And it's actually the sorted value. So we have bell pepper first. Then we have cabbage, cabbage, celery, onion, and then potato. So it's taking this list and it's sorting the values, and then it's returning those sorted values. Great point in the chat, which was does sorted mean alphabetical error? So by default, and you can change, we'll see how we can change the order that things are sorted in, but by default, I'll put this up here. Numerical data types, so those ints and floats, are sorted in ascending order. Okay, for strings, are sorted alphabetically based on the Unicode code point value, okay, of each character. And let me explain what that means. So strings are sorted lexicographically, so in dictionary order. So that means that uppercase letters come before lowercase because of their Unicode values. So I'll put that uppercase letters come before lowercase letters because of their Unicode value. So you don't have to know too much detail about this, but just know that the computer understands A to really have a Unicode value of 65. And then lowercase a, right, has a Unicode value of 97. So when it sorts it, it's going to put uppercase letters first, followed by the lowercase letters. So again, when you have numerical data types, it's typically sorted in ascending order, and then you can think about strings as being sorted alphabetically. If you want to go a level deeper and gain a little more understanding, it's that each character has a Unicode associated with it, and that is how Python actually sorts those string characters. Okay. And again, coming back here, you can see we had veggies, we applied the function, it returned a new value with those sorted elements. Let's go ahead and use our method. If I have fruits, it's a list, and it's going to have pineapple, apple, kiwi, and banana. Okay. And if I do fruits dot sort, right? So this is a method. If you remember the syntax, it's the object. In this case, it's the list that we're interested in, fruits, and we have a period, and then we have our method name, which in this case is sort. Okay. Then when I run this, It doesn't return anything, right? Because it's a method. Typically, those don't return anything. But if I look at the original list, I can see that it has reordered it and modified that list in place. So now apple comes first, then banana, kiwi, and pineapple. Okay. We had gone over here how by default, numbers are in ascending order and then strings are alphabetical, but you can actually create your own sorting criteria. So let's create our own function. So to create a function, I have the def keyword, and then I have my function name. Okay. Then I have my parameters, a colon, and then I have my body. I'm going to say output is text at -1 and return output. So what this function does is it will take in some sort of text and it's going to just return back the last character or the last letter of that text, okay? Again, this is just a function to return back the last letter of a string. So now I can actually apply the sorted function. Remember this function, we had applied it to veggies. It returned a new list with the sorted values. And notice how, because it's a function, it's returning a new list with the sorted values, but it's not changing the original, right? Veggies is still on, like, the values still start with potato, then celery, cabbage, bell pepper, and onion. That's something to note. Okay. So if I take sorted, I can now have veggies, and I want it to be sorted based on my function last letter. So if I run this, it's taking my list veggies and it's sorting it based on this function last letter. This function last letter that we defined returns back the last character, right? The last character in the text. So it's sorting it based on that last character. E, then N, then O, then R, and then Y. So there's a default on how you can sort things, but you can also create your own sorting criteria. Okay. Does that make sense so far? Okay, getting some thumbs up. Great. Okay. So let's go through a slightly more complicated example. Okay. So I have students per class. And let's say this is a list. And within that list, I have a sublist. So this is going to have grade 9, and there are 20 students. Then in grade 10, there are 17 students. And then in grade 11, say there are 13 students. And then in grade 12, there are 22 students. I can paste this one into the chat. Just remember it's not going to be there once the recording is done, but I know that one's a little bit longer. Okay, so we have a list, students per class, and within it there are sublists. Each sublist indicates the grade as a string and then the number of students as an integer. Let's say I want to sort this list based on the number of students in each class. Right? So I want it to start with grade 11 because it has the smallest, and then I want next to be grade 10, followed by grade 9, which is 20, and then finally grade 12, which has the most, which is 22. So let's define a function that we can use for our sorting criteria. I'm going to call this function second element. Okay, and it's going to take the second element. So remember in Python things are 0 indexed. So if we want the second element, we say item at 1. Okay, return output. So I've now gone ahead and defined my list, defined my function for the sorting criteria, and now let's go ahead and apply the dot sort method. Remember, this time before we just used the function, let's use the method with this criteria. So I'm going to say students per class. I'm just hitting tab on my keyboard to autocomplete. And then I'm applying the sort method. So I have a period and then the sort, which is the method name. And then I can have the key, which is the sorting criteria. And I want it to be second element, which is this function I've defined here. So this is a method, so it is not going to return any list. It's just going to modify the original in place. And when I look at the original, I can see that it's now sorted it based on the number of students in each class, right? So it's gone ahead and used this function that I defined, which extracts out that second element, and it's sorted based on that function. Okay. That was the last thing that I wanted to talk about when it came to lists. I know that was quite a bit of information. Tuples and sets, I think, are a lot easier, and those are the next two that we're going to be covering. But in the meantime, are there any questions on the content that was just discussed? Nope. Okay. All right, we can move on then to tuples. All right. So we saw that when we were working with lists, they were mutable and they were ordered, right? They were mutable because when we changed, we saw with the sandwich situation, if I changed one element if I changed that list, any variable name that pointed towards that list would also update. In the sandwich example, Moniz had a cheese sandwich, and I also pointed to that cheese sandwich, but when Moniz changed her sandwich to now be a ham sandwich, I also had to have a ham sandwich. I also pointed at that, and it changed, and so then I also had that new value. Now, so we said that they are mutable and then they're ordered. And they're ordered because Python is going to take in the sequence that the elements are in, and it's going to preserve that sequence and maintain it. Tuples, which are the next data type that we're going to introduce, are immutable, but they are ordered. So again, tuples, and let me write this down, tuples. So let me say lists, and there's a really handy table that I'll paste in from the slides at the end that summarizes everything, but lists are ordered and mutable. Tuples are ordered and immutable. So this means that once I create a tuple, I cannot change it in place. If I then make any modifications, it's going to assign it a new location and point to that, right? So it's just like how when we were working with the sandwich example and we had a string that's immutable. So Moniz had a cheese sandwich. She decided she wanted a ham sandwich. That's fine because Python then pointed to her ham sandwich in another place in memory, and I still was referring to my cheese sandwich. Okay, so tuples, they're immutable, but they are ordered, so they have a sequence that is preserved and maintained. So the way that we create a tuple is by having round parentheses. So I can have mutable synonyms. I'm going to say changeable, fluctuating, inconstant, and variable. Okay. So mutable synonyms. You can see here we have the tuple. It is ordered in that it's maintaining the same order that I had indicated here, right? I said I want changeable first, fluctuating second, inconstant, and then variable. And you can see that that order is maintained and preserved, but it is immutable. Okay. If you want to create an empty tuple, you can just have empty parentheses. Okay, this is the conventional way to create an empty tuple. You can also create an empty tuple. You can also make an empty tuple by having the tuple function. So I can say also tuple. Okay, and then I'm going to say tuple. So I'm just using the tuple function and having those parentheses. A tuple is just another data type. So we talked about ints, floats, strings, booleans, and then we said all of those are single values, and we said, okay, today we're going to talk about data types that hold collections of values. They hold more than one value. We just talked about lists, and now we're talking about a new one called a tuple. But a tuple has a little bit of a different behavior than a list in that it is immutable. Okay. All right, so that's how you can create an empty tuple. And I said that tuples are immutable. So what do we think is going to happen when I try to apply a method? Remember, methods change the original data type in place. They modify, it's like how we had a list and we changed it to then become the list was a cheese sandwich and we made it into a ham sandwich. We changed the original, and that's because a list is mutable. But now I'm saying I want you to take my tuple and I want to, and you cannot, and a tuple is immutable, but I'm trying to apply a method. So what do we think? Yes, I'm getting some responses in the chat and we get an error, right? This doesn't work because this append method is trying to modify my tuple in place, but you can't do that because it's immutable. So that's why we get an error being thrown. Yes, and the question in the chat, that's correct. Tuples are defined with those round parentheses around them, whereas lists have square brackets around them. Okay. So we can't really apply methods to a tuple because methods typically will modify them in place. But we can apply functions because a function's not going to do anything to the original. It's just going to return back a new value. So we can apply functions to tuples. So if I do length, mutable synonyms, you can see that I get back 4. Mutable synonyms, you can see, so this is my tuple, mutable synonyms. And when I take a look at applying the length function, I get back 4 because there are 4 elements inside of it. I can also apply that sorted function, right? Because it's not changing the original in place, it's returning back a new value, which is fine. Sorted, it go ahead and changes, returns back a new one, but it has here the same order because it's still in alphabetical order. And if I do mutable synonyms and I apply the addition operator, modifiable, shifting, okay, can see that now when I have the addition operator again, it's concatenated the tuple. So it's combined and concatenated these two tuples together. But even though I just applied all of these functions in this operation, mutable synonyms is still the same, right? It hasn't changed from the original value because it's immutable. So when I apply these functions, it's returning back new values. When I apply the operators, it's also returning back new values, but the original tuple is still the same. Okay. And again, when I talk about ordered and unordered, we're referring to the sequence or the arrangement of elements within the collection being maintained. Okay. So that was tuples. Let's see if there's any questions. Oh, okay. I think Pedram's answered it. Yes, this was a good point, actually. When I applied the sorted function to the tuple, it returned a list, because if we look at the documentation, sorted is actually just going to return a list. So that's the way that this function works. Okay. So that was tuples. We're going to talk about sets now, and I think these are pretty easy to grasp and to wrap our heads around. So sets are another built-in data type. So again, lists and tuples are data types. They have collections of values, and now we're introducing a third one called a set. I'm going to take this comment and paste it down here so we can see it. It said, lists are ordered and mutable. Tuples are ordered and immutable. Now we're talking about sets. They are mutable, but unlike lists and tuples, they are unordered and distinct and are also mutable. Okay, so we're going to talk about what unordered and distinct means, but they are also mutable. Okay. So if they are unordered, we say that the elements do not maintain any specific order, and that the order in which you iterate over them is not going to be the same as the order in which you inserted them, right? Because before, when I had my lists and my tuples, whatever order I put those values in, it was preserved and maintained every time. But that's not the case when it comes to a set. And distinct means that all elements are unique. So this means that when you create a set, or if you add elements to it, the duplicates are going to be automatically removed. And if you tried to add an element that is already in there, the set's not going to change. Okay, we'll see some examples of this. If I have the set things and I say coat, lock, box, book, apple, hair, xylophone, lock, and I'll paste this one into the chat. Just remember it's gonna disappear after the call. Okay. So you indicate that something is a set by having curly braces around it. Okay, so lists were square brackets, tuples were around parentheses, and then now sets are curly braces. Okay. Now, when I take a, so I've defined my set here, right? But when I actually look at the output, first, notice that it's unordered. So the order that I gave it, coat first, then lock, box, book, etc., that order is not maintained or preserved. Okay? It goes and it changes that order. Additionally, it's distinct. So notice how lock shows up here and here, right? So lock shows up twice, and book also shows up twice. But when I look at the set, lock is only showing up once and book is only showing up once. It's distinct. Each element is going to be unique. It is going to then remove out any duplicates. Okay. So, if you were, let's say we had a list, okay, visitor, postal codes. I'm going to do M5R, M5B, M1M, M1M, and M1T. Okay, so I've just created here a list that has square brackets. That's how we defined a list. And I have all of these postal codes. Now, let's say I want to remove any duplicates, because I can see M1M is showing up twice, right? Showing up there and also there. A really easy way to make sure that you just remove all the duplicates is to turn this list now into a set. If I take this list and turn it into a set, the nature of a set, the set itself is then going to automatically remove out those duplicates. And now I can see M1M is only showing up once. Okay. There's only one way to create an empty set. And that is to just use the set function. Empty set, going to be set function, okay? And now I've created this empty set. Okay. So since sets are mutable, we can add and remove items and the set will be modified in place, right? It's just like with a list with those sandwiches, you can change ham and cheese and vegetable and whatever, and it's going to change the original in place. What that also means is that if you have more than one variable pointing towards that set, when you change it, all of the variables that point to it are going to also update and change. So we had the set things that we created earlier. You can also use the in operator. This is just a little tip. So you can check for elements inside of the set. So if I said lock in things, it's going to return true because it does find lock in the thing set. Okay. So if I did things dot add, so this is a method, right? Because I have the syntax of having the period, then the method name. The method is going to go ahead and update the original and modify it in place. It's going to try to update things and add lock to it. But when I take a look at things, you can see that lock hasn't been added because it was already there and it's distinct. So it's not going to add a duplicate in. But if I did things dot add mirror, and then I took a look at things again, you can see that now it has modified the original and added mirror to it, right? You can also apply the method remove, things dot remove apple. And you can see that it's, again, I've applied this method, this set method, and it's gone ahead and modified the original in place. So it's gone ahead and removed apple from the original, and it's updated there to not have apple. But I said that sets are unordered. So if we actually try to slice them or access them by their index, we're going to get an error because they are unordered. Okay, we're going to go over a couple of set operations now. And then I think after this, that will be a good spot to maybe end off the live learning session, and we'll go over the assignment. And then after that, if there are any questions, I can answer them. And again, Pedram and Moniz are going to be here for some until 12 p.m. to answer any more questions that you might have. Okay. So let's take a look at some set operations. I'm going to have my first set be rainbow, red, orange, yellow, green, blue, indigo, and violet. Okay. Then I'm going to have Olympic flag. Red, green, yellow, blue, and black. All right. So I've defined these two sets, and let's apply an operation So I'm going to introduce first the difference operation, difference method. This is going to find the values in the first set that are not in the second, okay? So if I do rainbow dot difference Olympic flag, it's finding all of the values that are in rainbow but are not in Olympic flag. As you can see, indigo shows up in rainbow, but it doesn't show up in Olympic flag. Orange shows up in rainbow, but it doesn't show up in Olympic flag. And then violet shows up in rainbow, but it also doesn't show up in Olympic flag. If I did Olympic flag dot difference and I did rainbow, okay, I can see it's going to look for all the values that show up in Olympic flag, but not in rainbow. And here I have black, right? Black shows up in Olympic flag, but it doesn't show up in rainbow. Okay. We can also use, let's say it's the symmetric difference. And this is going to find the values that are in only one of two sets. So for this one, it's going to find the values that are only in one of two sets. So if I did rainbow dot symmetric difference and then Olympic flag, you can see it's providing all of the values that are in rainbow and Olympic flag that are not in the other. Okay? So black, indigo, orange, and violet. Can also have intersection. I think that was actually a question in the chat, how to see what they both have in common. And this is going to find the values that the two sets have in common. Okay. So we're going to do rainbow dot intersection Olympic flag. Okay. And it's going to return back all the values that are in both rainbow and Olympic flag. So here we see it's saying blue because blue is showing up in both. It's giving green because green is showing up in both. It's giving red. Red comes in both. And then also yellow. Yellow also shows up in both. Okay. So it's giving back the values that return, it's returning back the values that both sets have in common. Okay. We are also going to show union. So union, and this is going to say combines two sets to get the unique values in both. So if I did rainbow dot unique, or sorry, dot union Olympic flag, it's returning back all the unique values that appear in both of those sets. Okay. So that's what's being output there. Okay. I think this is a good spot to end for the day. That was everything I want to discuss about sets. And when we come back on Tuesday, we're going to introduce our final data type for collections of values, which is the dictionary. And then we're also going to talk about for loops and while loops. And then we'll continue on with probably going over how to read and write files. So I'm going to just open up the assignment now. Give me one moment. Okay. Okay, I think everyone should see my screen. Is the assignment open? Okay, great. So, in this assignment, you are just going to take the Jupyter notebook that is on the GitHub repository, and all you're going to do is fill in your code anytime it says your code here. So right here, you're going to add in your code, and then right here, you're going to add in your code, and that's it. Okay. And then it also explains the pass and fail criteria. So let's go over everything step by step. We're going to be creating an anagram checker. Okay, so an anagram checker is, the point of it is that you're going to have this function, you're going to define this function called anagram checker, and it's going to take in two parameters, which we've called here word underscore A and word underscore B. So we've already helped you write out your function header. It's the function name, right, anagram checker, and then the two parameters, word A, word B. And what happens is you have to fill in the body of this function such that when we call and use the function, it's going to take those two words and it's going to check whether or not they're anagrams of each other. So what that means is if all the letters that show up in the first word also show up in the second word. I know sometimes folks can kind of go into a lot of detail on what an anagram is, and all we're interested in is whether or not all the letters that show up in that first word are the same as all the letters that show up in the second word. Okay, so in this case, oh, and the other thing is for part one, we are going to assume that uppercase letters are the same as lowercase letters. Okay, so for part one, assume that uppercase letters are the same as lowercase letters. So for example, if we had silent, if this is what happens when we call our function, we have silent and listen as the words, as the arguments that are passed, right? So this is our first argument and our second argument. Our anagram checker, when we call the function like so, it should return true because all of the letters that show up in silent also show up in listen. So all the letters that show up in silent also show up in listen. And we do not care for part one with the uppercase and lowercase letters. So it should return true. But if we call our anagram checker with silent and night, it should return false, right? Because, for example, silent has an E in it, but night does not have an E in it. Okay, so it's going to return back false. And again, if we run anagram checker with night and thing, it should return true because all the letters that show up in night show up in thing. They have the same letters, and we do not care in part one about the uppercase or lowercase letters. To answer the questions in the chat about this, spaces are ignored. I'm going to say nope, spaces will shouldn't. Yeah, we're going to, like, if there's a space in silent, for example, and there's no space in listen, I think it will still return false. Okay, so the string itself, whatever characters are showing up in the first string have to show up in the second string. And then to answer the second question, do we consider these two words anagrams, sock and socks? We do not consider them anagrams, okay? Because sock has one S and socks has two, okay? So the exact same letters have to show up in both the first and the second. So if you have two of one letter in the first, you have to have two of that same letter in the second. Okay? And do they have to make actual words found in the dictionary? No, you don't have to check if they are actual words, just as long as the letters that show up in the first are the same as the ones in the second. So you do not have to check for if it's a real word. Okay. So you're going to put your code in here. And then when we run it here, we've created some of these oh, I don't know why there's a check mark showing up on my screen. That might be a Zoom thing, but we've written out some calls that you can use. So these are going to call your functions, and then you can do some checks, right? So this is the same here. It should give you true. This silent and night corresponds to this second example. It should give false. And then this third one should provide true. So you can go ahead and call your function and make sure that it's providing the expected output. Okay. Now, in part 2, we are going to add a Boolean option, so a third parameter called is case sensitive. Okay. And this is going to return, so this here is going to be true or false, right? So the is case sensitive is going to be true or false. And it's going to tell you whether we care about case sensitivity. So if it is true, we do care about the case sensitivity. If it is false, we do not care about the case sensitivity. I'm going to repeat that again. For part 2, we now are adding in a third parameter, is case sensitive. It's a Boolean, so it's going to be true or false. And it's going to tell you whether or not we care about the case sensitivity. So if it is true, you are going to make sure that you take into account the uppercase and lowercase letters. And if it is false, it doesn't matter. You don't have to take that into account. So for example, when you run your code, right, here we have silent and listen and false. So we're saying, okay, we do not care in this case about the case sensitivity. So all the letters are the same, and we don't care that this is a capital S, so we return back true. However, if we had the same thing, but we had true being passed for the is case sensitive parameter, we're going to get back false, because here we have a capital S, and here it's lowercase, and here we have a lowercase l and a capital L. Okay, so again, that is going to be the output. Some tips now on how you can solve this. And everybody's code can be different. You might approach this problem a different way than one of your peers, but I really recommend using the sorted functions that we had looked at today, right? So we can apply the sorted function and take a look at the letters in a chronological order or that alphabetical order, right? And then also, when you are looking at if you do not care about the case sensitivity, I suggest applying string methods that can make all of the letters either all uppercase or all lowercase. So again, if you do not care about case sensitivity, make all your letters all uppercase or all lowercase and then compare them, because that's going to make it easier for you. And you can do that using some of the string methods that we talked about in our previous class. We've also hinted at there being some conditions, right? So here we're saying if case sensitive is true, we want you to do one thing, and if case sensitive is false, we want you to do something else. So in part 2, it may also help to use some if-else statements, okay? Because those are checking if certain conditions are true and then executing code accordingly. The criteria to pass this assignment is just that all the code cells execute without errors and provide the expected outputs, and then try to make sure that your code is organized, concise, and please include comments to help when necessary to explain, what the logic is behind your code. So I hope that helped. Are there any questions? Okay, I'm not seeing anything that hasn't been addressed in the chat. So in that case, we can end the class here. A reminder that actually I'm going to go ahead and update the assignment deadline on the GitHub repository. So this is not due December 1st tomorrow, it's due December 2nd at 11:59. And that's everything. And I'll post this live coding notebook as well right after class. Thank you, everyone. I hope you all have a great rest of your weekend. Oh, yes, Amit, I see your hand up.
Yeah, like these are two different parts of the program. Although we'll be writing in specific code blocks, but do we need to submit at two different times, or we just committed in the one go?
Yep, that's correct. Just one file, and just fill in your code where it indicates there and here.
Sure. Thank you.
Yep, no problem. If case sensitive is true, it means that you are interested in the upper and lowercase letters. So here, because it's true, we return false because the uppercase and lowercase don't match, right? We have a capital S in silent, but not in listen, and we have a capital L in listen, but not silent. I hope that answered that question. Yes, a hand up. Anise, I
Quick
think?
question. Hi. Uh, so once we finish the exercise, how do we upload it? Is it like we do like the first assignment where we upload it back to or how does it work?
Yeah, it's going to be the same as with the shell in
Okay.
Git content. If you have questions on submission details, reach out to the learning support, but if you follow the instructions that the DSI has posted, you should be fine.
Okay, perfect. Thank you.
No problem. Okay, great. Yeah, I will see everyone in Tuesday's class. I wanted to thank you all again for your understanding with having to move Thursday until now. This recording will be posted, and you can refer to it as you'd like. And I'll see everyone on Tuesday. Moniz,